What? No. Get out. Welcome to my step-by-step guide for solving systems of equations. In this video, we're going to be going through the intuition of how to solve these things as well as going through some examples. So let's get started. When we are asked to solve a system of equations, we are usually given multiple equations. In this case, we have two linear equations. Each of these has two variables. And we're asked to find values for those variables that make both equations true at the same time. So one way to solve a system of linear equations or a system of equations in general is to graph both equations. So here I have the two lines graphed. So the orange line goes with the orange equation, the blue line goes with the blue equation, and the set of variables that makes both of these true occurs where they cross. That is the point that both of these have in common. So this set of linear equations has one solution, which is right where they cross. Sometimes you can have a system of linear equations where the lines never cross. And in this case, we actually have no solution. The cases where we have no solution, if we're a system of linear equations, are always cases where both of your lines have the same slope. Lines with the same slope are parallel and will never cross, so there's no solution. So here's an example of solving a system of two linear equations. If we want to solve this system, y equals 4x minus 9 and y equals x minus 3, since we know y is equal to both of those things, they must be equal to each other. So we can set these two equal to each other and say that 4x minus 9 must be equal to x minus 3 since both are equal to y. Then we can use some algebra to try to get x by itself. So in this case, I have subtracted x from both sides. Then I can divide everything by 3 because I see everything is divisible by 3. Now I can add 1 to both sides and I end up with x being 2. So I know that x has to be equal to 2, but now I need to find what y is when x is 2. So I can plug in 2 for x in one of the equations. It doesn't matter which I choose. I've just chosen the one that seemed easier. And 2 minus 3 is negative 1. So this system is solved for x equal to 2 and y equal to negative 1. So here is the ordered pair for that point. Sometimes you're told to solve these equations in a specific way. For example, using substitution. What that means is you have to get one formula in a format where you can plug it into the other formula. Here's an example. I can rearrange x minus y equals 13 to just have x by itself. So I found that x is equal to 13 plus y. Now that I have an equation for x, I can plug that in for x in my other equation. So now I have 4 times 13 plus y plus 2y equals 10. Can distribute the 4 to get 52 plus 4y plus 2y equals 10 and combine like terms and subtract 52 from both sides, giving me 6y is equal to negative 42, which gives me y is equal to negative 7. Now that I know y, I need to find x, and I'm going to plug y into the easier of the two equations. I end up with x plus 7 is equal to 13. Subtracting 7 from both sides gives me x is equal to 6, and I end up with the ordered pair 6 comma negative 7, which gives me the solution to this system of equations by using substitution. The other way that you might be told to solve a system of linear equations is by using elimination. So here's an example of how we would use elimination. Usually you want to use elimination whenever you notice that there are terms that you can cancel out. So in this case, I can stack my two equations. So first I'm going to start with negative 8x minus 10y equals 24. And I notice that if I multiply my other equation by 2, I'm going to end up with a positive 10y. Negative 10y plus 10y cancels out my y's in my equation. So if I multiply my entire second equation by 2, I end up with 12x plus 10y equals 4, and I can add these two equations together. So what I do is I add straight down, so I end up with negative 8x plus 12x, negative 10y plus 10y, and 24 plus 4. And I end up with 4x, then my y's cancel out, and I have is equal to 28. Dividing by 4, I end up with x is equal to 7. This is called elimination because we've eliminated the y's. Now that I have my x, I can plug that into either equation. And in this case, I chose the second equation. So I have 6 times 7 plus 5y equals 2. I need to solve for y, so I've multiplied my 6 and my 7 together to get 42. I can subtract 42 from both sides, divide by 5, and I end up with y is equal to negative 8. This gives me my ordered pair 7, negative 8 as the solution to this system of equations. A system of equations does not always have to be a system of linear equations. Sometimes you can have both linear and quadratic equations or other types of polynomials as well. So I'll show you an example that uses a quadratic equation. Let's start with the simplest quadratic equation, y equals x squared, and then for our linear equation, we'll use y equals negative 1/2 x plus 2. When I graph both of these, you can see that there are actually two places where they cross, and these are the two solutions to this system of equations. When you have a system of equations that includes a linear and a quadratic equation, you can either have two solutions, you can have one solution, or you can have no solutions. So here's another example. Keeping y equals x squared, we can change our line to now have y equals 4x minus 4. And when we graph it, it looks something like this. And you see that the blue line is actually tangent to the orange curve. And it's tangent at this point. So this is the point where both of those things are true. It's the point where they cross. And in this case, we only have one solution, that one point. I mentioned that we can also have no solutions. So giving us a different line, in this case, a line that will never touch our quadratic curve, we end up with no solution because there's no place where they touch, just like when we had our parallel lines. Let's do a couple quick examples of working with quadratic equations. So if we are to solve this system of equations where we have one quadratic curve and one line, since we have them both in the form y equals something, we can set them equal to each other, because both are equal to y. And I can add 2x and add 3 to both sides, so I end up with 4x equals x squared. Dividing both sides by x, I end up with x is equal to 4. Now that I know what x is, I can plug that in, and I choose to plug it into the linear equation just for simplicity. And I end up with y equals 8 minus 3, or y is equal to 5. So 4, 5 would be the solution to this system of equations. This is a case where we have a quadratic equation, but there's only one solution. So this would be a point where there's a tangent line. If we solve this system of equations, we actually will end up with two solutions. So again, both are in the form y equals something, so we can set those somethings equal to each other. I am again going to add 2x to both sides, and this time I'm going to add 15 as well, so I end up with 12 plus 4x is equal to x squared. If I get this in the format of x squared minus 4x minus 12 equals 0, I can solve this quadratic equation. I'm going to choose to solve it by factoring. So I end up with x minus 2 times x plus 6 is equal to 0. This means that one of those two terms, or both, must be equal to 0 for this to be true. And the values of x that make that true are x being 2 or negative 6. So those are my two different options. Let's start with x being equal to 2. When x is equal to 2, I can plug it in to my line and have y is equal to 4 minus 3. Or y is equal to 1, and that gives me one possible solution, 2, 1. But I also have the solution when x is equal to negative 6. So if I plug in negative 6, I end up with y is equal to negative 12 minus 3, or y is equal to negative 15, which gives me the point negative 6, negative 15. And these would be my two solutions to this system of equations. Remember, just like with most math concepts, practice makes perfect. Solving systems of equations can be challenging, but with time and practice, you will become a pro. So take your time, Double check your work and don't hesitate to ask for help if needed. Thanks for watching. If you enjoyed this video and thought it was helpful, please leave it a like and also check out this video next. And please subscribe to Rosie STEM for more helpful math tutorials. Thanks and stay curious.